All right, so this lesson, Foundations of Math 10, 3.5, we're going to talk about trinomials, and that is they're polynomials in this form right here. It's a form of y equals x squared plus bx plus c, where b and c are just coefficients, okay? B and c are just numbers. So we're going to look at trinomials like we did last section, but we're going to build on that a little bit. All right? So let's say we have now, this y equals, okay, is actually not in the title of your book. That's a function, and we aren't going to graph it actually, so don't worry about the y equals. It's just going to be expressions, I guess, trinomial expressions. So don't let that fool you, I guess. That was maybe just my fault. Okay, so let's say we have something like this, x squared plus 10x, right, plus 25, okay? X squared plus 10x plus 25. Now this is a trinomial in this form. So what do we know about this? Well, there's three terms, right? There's three terms. And what we've been doing in 3.4 is we've been looking at greatest common factors, right, of polynomials. So is there a greatest common factor that you can see between these three? So look at each one of these terms. Is there anything common? All three terms? Looks like there maybe is a 5 that's common to the second and third term, but not to the first one, right? So that's always what you look for first. You look, are there any greatest common factors you can pull out? In this case, there aren't. So what do we do? Can we still factor this somehow? And the answer is yes. So we're going to come back to this example, but I want to show you a couple other things first. And we did this a little bit yesterday, but I'm going to go over the FOIL method again, and that is the method of binomial expansion. Okay, so we talked a little bit about FOIL. I'm going to put that up here. Who remembers what these letters stand for? What does F stand for? Okay, F stands for, I'm just going to make this in a different color, first. Yes. What does the O stand for? Outside. And of course, we're talking about terms in this binomial multiplication. I is inside, and L was last. Very good. Okay, so like I say, we'll come back to this example, but let's take some other examples like, oh, I don't know, x plus 2 times x minus 3. Okay, so those are two binomials. So in the title we have trinomials because there's 1, 2, 3 terms. These are binomials because bi means that there are two terms, right? So this is binomial multiplication, or binomial expansion, where you have a binomial times another binomial. So FOIL method, there's a little bit of a shortcut. So first terms, we multiply those together, we get x squared. Outside terms, this one times that one. Consider the sign, x times negative 3 turns into a minus 3x. Now we move to inside, so 2 times x is plus 2x, and 2 times negative 3 is minus 6. Okay, is everyone okay there so far? FOIL method, all right? Something you should be familiar with. What do we have to do next here? Do you remember what we talked about last lesson? Am I done? Is this okay to leave just like that? Circle it, we're done? Or is there another step of simplification we got to do here? We talked about what yesterday? Simplifying, yeah. What do I need to simplify here in this expression? Right. These two terms are called like terms, remember? Like terms, the same variable, the same exponent on that variable. So that means we can simply combine the coefficients or the numbers on those terms and then write that as one term. So it's going to look like this. The x squared does not have another like term, so we just leave that there. But negative 3x plus 2x is what? Yeah, it's negative 1x, or we wouldn't put the 1, we just put negative x. So those two are combined to form this one middle term. All right, and then minus 6, right? Okay, that's good, So there's an example there. Let's do another one. I'm going to leave it on the screen here. Let's do another one like x plus 5 times x plus 5. Okay, so you can do this, right? What's another way to write this? Another way to write this would be x plus 5 squared, right? Remember we talked about squares and square roots and cubes and cube roots, remember that? So that's another way to write this. That's what that means right there, okay? X plus 5 all squared means x plus 5 times x plus 5. All right? So let's do this binomial expansion. That's how we multiply properly. So again, first terms, x squared, I'm a little bit faster now, plus 5x plus 5x plus 25. So if I gather like terms, now I have x squared plus 10x plus 25. Okay. So a couple things I want you to notice. First thing I want you to notice, and I don't know if any of you would have a tendency to do this, but when you see this right here, x plus 5 all squared, please do not, it's not equal to this, x squared plus 25. Please do not do that. A lot of students do that. All the way through high school they do that. It's not quite right, and you know what? We see that it's not quite right because this is the proper expansion. That's the proper answer. So when you multiply a binomial times another binomial, or by itself, when it's squared, you can't do this, okay? Please promise me, swear to me an oath that you will not do that, okay? Even just in your heart right now. Just say to yourself, I will not do that ever in my entire life. I'm serious. Don't smile. This is serious. This is serious. You're smiling too. Of course, I'm joking. Anyways, can everyone see that though? The proper expansion is not just x squared plus 5 squared. That's not the same. Can't do that. Okay, but the second thing I want you to notice on the same screen, what do you notice? There's something, look on the screen. Do you notice anything? Any connection anywhere to anything? After this example, what would be the other thing that I might want you to notice? Sorry, yeah, I heard somebody say, what? The first thing I wrote down. Oh my goodness. Very good. Let's go back to the very first thing I wrote down. Look at this. That's the very first thing I wrote down. Where do you see it again? Right here. Ooh, it was a little bit of foreshadowing there. Wow. What are we doing bringing English into this math class? Excuse me. Don't ever do that again. No, I'm just kidding. I'm just kidding. Just kidding. So yeah. Now here was my question before. I don't know if you guys remember this, but I was like, okay, if we look for common factors, there are none. But can we still factor this thing? And yes, there is a way to factor. And this whole lesson is about how to factor trinomials, knowing where they come from. Okay? And we're going to try and factor trinomials into a product of two binomials. So I know this screen is really messy now because I'm going to erase some stuff. Okay? But I want you still, not all that. That bracket can stay. But I'm going to erase some stuff here. And what I want you to notice, this can all go to. I want you to notice just a couple important things. This right here, look at this one. That is our polynomial. Look at the products that it came from. Those are the products that it came from. This is the polynomial. Look at the products that it came from. And you can also look at the in-between steps too. Because remember, what we're going to have to do, really, is we're going to have to work backwards. We're going to start here, and we're going to factor. We're going to go back up to this. So factoring is the opposite of expanding and multiplying out, okay? So it's the opposite. So we have to now go backwards. Look, check this out. X squared minus x minus 6. If we go back a step, what do we see in there now? Negative 3, positive 2. What's in the factored form? Negative 3, positive 2. Look over here. X squared plus 10x plus 5. If we work backwards, look what's in this middle row here. Plus 5, plus 5. What's in our factored form? Plus 5, plus 5. So there's a connection here. And what we have to try and do is find the connection. Okay? All right. Now, again, I'm going to erase some more stuff here. This is looking really kind of messy, but I want to keep this screen alive here. Okay? All right. What do you notice? What do you notice about -6 and about our factored form of this polynomial here? You notice what inside here? What's the connection between this right here, this whole thing, and -6? Come on, think about it. Eyes up here. Right. What's the connection between -6 and what you see inside this yellow circle up here? Okay, thank you. The +2 and the -3 multiply together to get you what? -6. So when you're looking at factoring a trinomial like this, you want to consider the factors of -6. It looks like those factors might be important in your final factored form. What about over here? What about 25? Do we see any connection between 25 and our factored form? Do you see the same connection? 5, 5. Okay, very good. Now, what else is connected? Do you see a connection between x squared and the factors? Where does that x squared come from? The two x's multiplied together. Good, good. Because remember, we're doing FOIL in reverse here, sort of. Is it the same over here? X squared? Is that this one times this one? It is. So, my final question then, what does this middle term have to do with the binomial factors? Look at the middle term. How is it connected? How, anybody? Charlie? Okay, so 5 plus 5 gives you 10. Okay, does that work over here in this other example? Does +2 plus -3 give you -1? Yes. The answer is yes. Okay? Okay, do we run into a stumbling block there? Is that too tough or what? Because all of a sudden you guys just got really kind of stare off into space-ish. No? Does that make sense? Is this too easy? Is that the problem? Okay. All right, so there's connections here. Very, very important. Okay? Now watch this. Don't write this down, but watch this. I'm going to do this pretty quick. Okay? The expansion of that, oh, that's an A and that's an X. Let's do this right. So the expansion of this, I'm going to do FOIL really quickly in my head, is going to be x squared plus 4x minus 12. Now, do you see how I got that so quick? Anyone see how I got that so quick? What did we just talk about? The x squared comes from these two. That's easy. Where did the 4x come from? Where did this 4 come from? Ah, 6 plus -2. Very good. How did I get -12 so quick from that? 6 times -2. All right. Very good. Okay, so here's another one. X minus 5 times x plus 2. What is this expansion going to be? Without even doing FOIL, without even touching the paper, what's my first term going to be? X squared. What should my next term be? Minus 3x. Does everyone agree? You see that? That's true. Minus 3x. And what about my last term? What should it be? Minus 10. That is absolutely correct. If we did a quick FOIL, we could double check that. Here it is. Plus 2x minus 5x minus 10. Combine those. 2 minus 5. Right? Negative 3x minus 10. It's correct. So, here's my question now. How do you factor this one? X plus 8x plus 12. What does that equal? Now I'm asking you to factor, so I'm asking you now to go backwards from expansion. Here's my suggestion. Look for a greatest common factor, none. make your two brackets, because you know what? If it's going to be factored, we're going to be having two binomials. So that's why I always tell my students, put the brackets out there first. What's the first terms going to be here? What are the first terms going to be? X and X. That's right, because they have to multiply to this. So now, what two numbers are we looking for in these binomials? Anybody? 6 and 2. Okay, why did you choose 6 and 2? Can you tell us? Because 6 plus 2 is 8, okay? And 6 times 2 is 12. That's very good. So both positive. So plus 6 and plus 2. From all that we've been doing here, from all that we've been gathering here, all the evidence we've been gathering, this is what we're looking for in this situation. So yes, very good. Now, if we were to check that, okay, so let's just give it a check here. And how would we check to see if we did this correct? We factored, so how could we check? Anybody? How could I check to make sure I did this right? Well, if you took this and you factored it, you broke it apart into two factors. What if you multiplied those factors again? What should you get? You should get the original polynomial back, right? So to check, you multiply the two binomials. X squared plus 2x plus 6x plus 12. That's x squared plus 8x plus 12. That's exactly what I started with, so you factored correctly. All right, so speak now. If you have any questions, circle your factored answer. Do you have any questions? We are, again, remember, we're looking for, when we're factoring trinomials, so let's maybe just formalize some of this stuff here, okay? When, write this down, factoring trinomials, remove greatest common factor first, if there is one. 2, okay, 2, I would say set your brackets out for the binomial factors, just like I did there. Remember I put the brackets out, the empty brackets. Set the brackets out for your factors. Fill in first terms with the square root of the first polynomial term. Fill in final terms with integers that, and this is really important, add to middle number and multiply to the constant in the polynomial. All right. So pretty important when factoring trinomials. Oh, that is spelled wrong. Trinomials. Thank you. Trimonials. Remove the greatest common factor first. Set your brackets out for binomial factors. Fill in the first terms with the square root of the polynomial first term. Then fill in your final terms with integers that add to the middle number and multiply to the constant. Okay, I'm going to do one more example with you here. Okay, one more example. Final example. And I'll set you off in your assignment. So, here we go. Negative 4t squared minus 16t plus 128. And I want you to factor this. So, first step says what? Remove GCF. Do we have a greatest common factor here? Is there any number that you can divide out of all three terms, or any variable that is common? You should notice that you can divide each of these numbers by 4. And even more than that, it's a good idea to try and make this first term positive, because in all of our examples, the first term was always positive, so that's going to be easier. I'll just tell you that right now. The first term being positive, that's going to be a little bit simpler for you. So let's take out a negative 4. What am I left with? T squared minus 4t, and then 128 divided by negative 4. Oh, that's going to be a plus 4. This is going to be then a negative 32. Okay? So that's first step done. Remove greatest common factor. Now we cannot forget about this factor when we're all done. That's going to be a factor. So just remember to keep that in there, and I'll try and remember to show you here what. But I just leave it in there. So the next step, let's leave the 4 there because it's already a factor. Now we'll set our brackets out. So this trinomial, if it's going to be factored, which most of these are going to be able to be factored for you, okay? This is what we're working on here. It's going to be 2 binomials. So we'll set out our brackets. Just empty brackets. Step 2, done. Fill in the first terms with the square root of the first polynomial term. Okay, so this is t squared. So we have to have t here and t here. And step number 3 is done. Now step number 4, we need to find out integers that add to the middle number and multiply to the constant term. So the middle number is 4, and the constant term is negative 32. Whoa. We got to think about factors of 32. This is where we go. Do this first. Think about what can multiply to the constant. If you list the factors, and it may jump out at you, it may not. So go ahead and do this. You can do this. 32, what are my factors? That's actually negative 32, so it could be negative 1 and 32. Do these factors add up to 4? No. They would add up to 31. So what about 16 and negative 2? I'm just throwing a pair out there. Do those add up to positive 4? No. What about 8 and negative 4? Those are factors of 32. Do those add up to positive 4? They do. So if you can do this in your head, great. If not, just start listing the factors off to the side. Right? They have to multiply to 32, and they have to add up to the middle term, middle coefficient there. So guess what? We actually have t plus 8. Make sure you remember the signs there. Plus 8. And then minus 4. Okay? Now just one note before we leave that. If you did this, negative 8 and 4, and you say, well, Mr. Maxwell, that adds up to 4 as well. That adds up to negative 4, and that's not what we're looking for. So that's not the pair. See? It's these two. They have to multiply and add to the proper things. So, we got that 4 out there. This is your final factored form right here, with 3 factors. Negative 4 as a factor, t plus 8 as a factor, and t minus 4 as a factor. Okay? Any questions? This is really, really important. Okay? Factoring is probably the most important thing in all of high school math. Like when you just think about what's the basic stuff that students need to know how to do, it's in every math that you see. Factoring is super important. So this kind of stuff here, really important for you guys to learn. So don't check out on here. But we are done the lesson. That's pretty much all we're going to do. I'm going to assign you some questions as practice from the textbook. Okay, we're not using algebra tiles. Algebra tiles are great, but we're not going to be using algebra tiles for this section. So I don't think I've assigned you any questions that say you must use algebra tiles, but if it does show up, you don't have to. Okay. All right. So there's the list. I'll look at that for a second, and I'll give you your assignments here.